Alright, let's go over the fourth example of finding the area of this regular three-sided polygon, aka the equilateral triangle. But now you are given the apothem being 6 feet, denoted by the lowercase a. And remember that the apothem starts from, the apothem is the distance between the center of the circle all the way to one of the sides of the triangle, and they are intersecting each other perpendicularly. So there's a right angles right there at the bottom intersection. And you can draw the apothem right here as well. They are intersecting perpendicularly. And right there. So this is 6 and 6. These sides are being bisected by this apothem. So this half is equal to this half. Like that. Since this is an equilateral triangle, we know all three sides are the same. So that's why all three sides are denoted by the same variable x. Because we are given the apothem, the first way of finding the area of this equilateral triangle is strongly recommended for us to use the formula for the area of any regular polygon, which is capital A sub reg poly, standing for regular polygon, is equal to 1/2 multiplied by the apothem multiplied by the perimeter, like that. But we don't know the perimeter, so we have to find it. So in order to find the perimeter, we have to find all three sides. So how do we find all three sides? Well, what I like to do is that I like to draw the radius of the circle by going from the center to not just one of the vertices of the triangle, but all three of the vertices of the triangle. So this is called the radius right there. And I like to make use of the given apothem. So how do I make use of that? Well, with the radius drawn right here, I'm going to select one of these three triangles. And again, I'm going to select the bottom one because it's easy for me to see. Using the bottom triangle here, I'm going to select the left half of the bottom triangle. So you selecting this left half of this bottom triangle, I'm going to have its hypotenuse, which is the radius of the entire circle. And it's going to look something like that. Oops, sorry about that. This is supposed to be the same dashed line that we saw. This angle here is 90. This angle, 60 degrees, is bisected by the radius. So this half, which is this one right here, is 30 degrees. If this is 90, if this is 30, this is 90, this has to be 60 degrees, like that. By the 30, 60, 90 triangle property, we know opposite to 30 degrees is the short leg denoted by a variable. I'm going to call it W. But at the same time, this short leg here is the apothem that we are given. So we know W has to be equal to 6 feet, like that. Opposite to 60 degrees is the long leg denoted by the products of the short leg, which is W and square root of 3. But we know W is 6 feet, so this right here is the same as saying 6 times square root of 3. But 6 times square root of 3 is actually equal to half of this entire base. Well, this entire base is denoted by the letter x. So that means 6 times square root of 3 is equal to half of the base, which is half of the x, so x over 2. So guess what? We can solve for x, which is representing the base, by multiplying both sides by 2, so that x can be by itself, like that. So that means we know that 12 square root of 3 feet is x, which is equal to the base of the triangle, the entire triangle, I should say. So there we go. Well, with the base being 12 square root of 3, we know this side is 12 square root of 3, this is 12 square root of 3, and this is 12 square root of 3. So the perimeter is going to be the sum of all three sides. So that means we are going to have 1/2 times 6 times 12 square root of 3 plus 12 square root of 3 plus 12 square root of 3, like that. Keeping the square root of 3, just adding the coefficients, we got 36 square root of 3, and at the same time, 6 times 1/2 is going to give us 3. So we got 3 multiplied by 36 square root of 3, which is going to give us 108 square root of 3 feet square. And this is the area. Oops, I should say like that. There we go. So this is the area of this regular polygon, or the area of this equilateral triangle, I should say, using the formula for the area of the regular polygons. Now, what about the area for the equilateral triangle itself? We know the formula for the area of the equilateral triangle is going to be square root of 3 over 4 multiplied by the side raised to the second power. But we know the side is what? 12 square root of 3. So all we have to do is just plug it in. So that means we get square root of 3 over 4 multiplied 12 over 3 raised to the second power, like that. We'll just expand it out by keeping the square root of 3 over 4 and using the loss of exponent, distributing the outside exponent to each of them one on the inside. We have 12 raised to the second, and we got square root of 3 raised to the second. Square root of a number raised to the second power means the square root and the power automatically cancel each other out. 12 raised to the second power is 144, so this means we have 3 square root of 3 over 4 multiply 144 multiplied by 3. Well, let's see, this is going to give us, I'll erase that, actually, I'll put it down here. Let's see, 3 times 4 is 12, right? 2, keep 1. 3 times 4 is 12, plus 1 is 13, right? 3, keep 1. 3 times 1 is 3, plus 1, plus the 1 we're keeping is 4. So we got 432 times square root of 3 over 4. But this is the same as 108 times square root of 3 feet square. And you see, we get the same answer. Now, what if we use the formula for the area of any triangle, which is 1/2 times base times height? Well, that's going to be easy because we know the base, but we don't know the height. Now, the height of this triangle is going to be the apothem plus this unknown side. We can opt to do that. Or what we can do is that we can find the area of each of these 3 triangles and then we add them together, because we know the height of each of these 3 triangles, which is 6 feet. So really using the formula for the area of any type of triangle, what we can do is that we can find the area of the entire triangle, which is going to be 3 multiplied by 1/2 times base times height. At that, this 3 comes from the fact that we got 3 triangles. This one, and this one. The base here is the respective base of each of these triangles. So the base of this triangle is the x, but we know x is 12 square root of 3. The base of this triangle is also x, and of course same thing for this. The height is of course the 6 feet that we know, so that means we got 3 multiply 1/2 multiply 12 square root of 3 multiply by 6. Well, this is going to give us 3 from the outside 3. Let's see, 6 times 1/2 is going to be 3. 3 times 12 square root of 3 is going to be 36 square root of 3. But hey, this is the same as 108 times square root of 3 feet square. That is the same answer that we got from top and bottom.